Please keep in mind that if this was an actual model, an actual production model, it will be made of many different pieces. So you will need to invest quite some time in the preparation of the geometry itself. So this is by no means an actual production final setup, but hopefully this is gonna give you some ideas. So let's have a look. On the top we have the model of the car. Here's where your geometry will come. Then I have a scatter and a Voronoi fracture. Then I'm setting the part to be deformable. You might remember the part attribute from what we did before to create constraints between pieces that have a different part. So this is basically the same exact thing. Now I'm setting the RBD configure. This name is not important at this point because this Voronoi fracture is creating a name. This name here is not going to be used. And then finally I'm setting the active attribute to be 1. Then for the driver of the car, what's actually driving the animation or the motion of the car, I'm using a box. I'm setting the name to be core. I'm setting the part to be non-deformable. So as you can see, you have two different parts. RBD configure is packing the geometry. And then I'm deforming. Sorry, I'm actually animating this box. So this is going to be the motion of the car. You can imagine you will get this from an animator, for example. And then I'm setting the core to be animated because I wanted Bullet to transform this object. And finally I have a wall that I'm gonna use as a collision for the car. I'm merging everything together. Now you can see that the box is animated, it's going towards the wall, but the metal part of the car remains in the same place. On the right I have the constraints. So these are the constraints between the pieces of the metal of the car. I'm setting some properties, so I'm setting the constraint name to glue. Later I will explain why we have this glue attribute rather than a twist. On the right I have this group of constraints that you should know now that I'm transforming the constraints to have a length of 0. Then I'm setting the properties of those constraints to be soft. So the constraint name is soft and the type it's all. And then I have a merge here where I'm bringing the box and the metal parts of the car. And I'm creating constraints between the metal pieces and the core. And I'm setting those constraints to be glue. So in here we merge all the constraints and we connect them to the second input of the DOP network. It's the same that we have been doing so far. So I'm not going to explain this, but I have the con-twist, con-rel here set to twist. Everything else it's the same. Additionally to what we had before, I have a glue. And this glue constraint, if I turn this on, this glue constraint, it's what's keeping the pieces of metal attached to the core of the car. So you can see that the pieces of metal are going together with the car, they are moving together. And lastly I have this bullet soft con-rel, which is creating the soft constraints. So if we go back up, these constraints that I have in the metal, so these are the constraints that are actually keeping together the pieces of metal, are soft constraints. And the cool thing about soft constraints is that they allow you to create metal deformations like the ones that you are seeing here. So if we have a much more complex shape or more pieces for this car, it will look much better because every single piece will be deforming on its own. But I will suggest you to have a look at the file on your own and experiment with different parameters and see what results you get. In general, this is exactly the same approach that we used for the tube and the box. The only difference is that we have some additional constraints. The reason I'm using this glue constraint is so the pieces remain together like a static solid object until it hits the wall. And then once it hits the wall, these glue constraints are going to break because their strength is very small. And because they break, then the only thing keeping those pieces together are the soft constraints. So you get this kind of behavior. And then I'm importing the pieces with this DOP import, transforming those pieces. This merge car, it's merging the pieces of the car fractures. Then I'm transforming them with the DOP simulation. And then I'm bringing the original model of the car before the fracture. And point deforming that with the pieces that are transformed. And then I'm using a delta mesh just to soften a little bit the geometry. And I'm merging everything together so you can see it. There is one additional thing that I kept on the file, but I would suggest you to have a look on your own, which is here inside the tree node. Dive inside and the result of this simulation it's gonna be this. And in here we are using pretty much the same techniques that we used before. If you remember the last setup of the box and the tube, this is exactly the same, but rather than having one box and a tube, we have one piece of geometry that it's animated and a tree. How we created this geometry and the fractures is not something I'm gonna explain here, but that's why I'm providing the file to you so you can have a look. You need to have a look first at what's on the left and then what's on the right, and then just carry on with the simulations. But there's nothing new here in terms of techniques that is different to what we have done